I haven't seen Jurassic Park.
What? Ever?
No, I haven't.
Damn. Okay.
It's one of the legendary films that's just not in my memory.
Wow. Not yet.
Not yet. Not yet. Does it stand up? I've noticed when you go to old movies, a lot of times they're kind of slow.
Okay.
They don't work with my TikTok brain.
You're on Twitter too much, aren't you?
Yeah, a little bit of Twitter, a little bit of TikTok. Actually, TikTok is kind of what got me and made me realize my brain didn't have a tolerance for the kind of attention grabbing that it did. Because I could do 3-4 hours on TikTok and it would wreck me. Yeah.
Wow.
Yeah.
We really have to self-regulate around that one.
Yeah. Or we just need better content. Like software devs have started taking to TikTok, which I really like. I like to see that. Electronics, a little bit, a tiny bit. Yep. Usually what I see, though, is chip decapping.
Oh, yeah.
Yeah, where they kind of like dissolve.
It's so aesthetic.
Have you? Do you know how that process works? I don't know much about it. Chip decapping.
They do it through a few different means. So basically chip decapping is just removing typically the epoxy covering from the top of the chips, or sometimes it's a little metallic can, or rarely for like military and space application ceramics. And I think there's typically two ways you do it with the epoxy. You can mechanically remove it, so you machine it off, or you use a solvent that's able to get into that. Well, not necessarily just a solvent, but you chemically remove it.
Gotcha.
And so from what I understand, you typically machine it down to some reasonable level, and then you use chemicals for the last bit, because the chemicals are, like pretty nasty stuff.
Yeah.
And I do have one friend, John McMaster, who is like quite famous in the chip, not just decapping, but reverse engineering circles. And there's a hackerspace, makerspace down in San Jose that a group of friends, including him, set up. And he's got these incredible reproductions of an RP2040 and a Starlink terminal receiver on the wall. Yeah, they're beautiful.
They reproduced it, so they
didn't remanufacture them, but I mean like a printed reproduction of the chip
I see,
massively blown up. It's really cool stuff.
That's really cool. It makes me happy. There's this idea that if we lost all the technology we had today, then we might not be able to get back so easily, right? So it makes me happy that maybe we could at least look at the chips we made and study them and maybe get back a little bit faster if, for some reason all the ASIC machines went away or something like that.
How long? Oh, that's an interesting one. That's optimistic. I take the other stance. I think we would be cooked. Yeah.
Oh, really?
Yeah.
If the ASIC machines went away.
Depends what level you go to. Like if you just like snap of the fingers, for whatever reason, every machine from ASML just blew up.
Right.
Like, okay, yeah. Like I think we would figure out a way back from there. But if we were, whatever it was, some like meteor hits the Earth and we're back and like whatever, 10% of the population survives. So you've got plenty of people who like kind of know what's up, but you didn't have stuff.
Yeah.
We are so spoiled for infrastructure.
We are. And a lot of the companies, like a lot of knowledge. Okay, so I guess this is kind of the point of academia, is like a lot of stuff gets published. But I do feel like in electronics, in chips, not that much is getting published in academia. It's really like baked into those companies. And so like there's a lot of security in our infrastructure kind of in those companies. It's not like open knowledge. Like, yeah, those are probably the hardest companies to create from scratch.
Oh, I think that's probably, it's definitely some of. I couldn't think of many harder. Both the actual fabs and the equipment manufacturers like ASML and Zeiss. But this is Taiwan's security principle, basically.
Right.
If you end up having a company that is strategically required by every world power, then like everyone's going to at least not want you to be invaded.
Right.
Or at least not destroyed is perhaps the minimum.
Right, or cut off or anything where we can't get our chips because we want our chips.
No, I mean, think about it. Like China has been threatening to invade Taiwan from whenever they gained independence in like it was 50s, because it was in the Revolutionary War.
It's a long time ago, yeah.
So they have said, we will retake you at some point. And then China built nukes and became a world superpower and they're still Taiwan's biggest trading partner.
Right. Oh, really?
Yeah. So,
interesting.
And so through all of that, it's pretty clear that they couldn't do, at least without a lot of it. And they're trying as hard as they can to recreate that ability to fabricate ICs. But it's hard. And they're going faster in some counts than anyone assumed, but it's still just really damn difficult.
Yeah, absolutely. And I think like one edge that when you look at China fabricating chips, one edge was the instruction sets. I think they manufacture like for some reason I don't think you have too many Chinese chips with ARM or x86 or whatever instruction sets, or if they do make them, they're kind of underpowered or something like that.
Yeah, right.
I think the instruction set is somehow related, but actually I don't really understand how.
Given the number of like Beats headphones and quote unquote Ray-Ban sunglasses I've procured over the years from dubious sources, no, I think that they can duplicate what they can very literally read from either what they had in the past, of course, or reverse engineer and sort of reinscribe in the same way that they're able to deconstruct a semiconductor and reverse engineer it is always the minimum viable level of copying. But there are a whole heap of restrictions on the IC design tools that practically the Western world, but particularly the US US companies are able to export to China, as well as just like they're not allowed to sell. It is IP blocks in some ways. I'm not sure if it's as much the instruction set, which is like everyone knows that. Like you need that to build the compiler, and the compiler is open source. But then to make a functional high performance processor from that's another step. Right.
Do you think that let's say that sort of, and I guess people have been saying this might happen for a while or whatever, but chips they stop getting so fast. It just seems like a really ridiculous thing to talk about, though, because we know that they're going to get faster, at least for AI, and everybody wants AI capabilities. So we're going to have a whole computational rat race for AI, and that could last decades. So it's like Moore's law may slow down, but it won't matter because there's going to be a whole new Moore's law on chips with integrated AI capabilities, right?
So I think that's typically right. I think the reason Moore's law has stuck is because compounding social factors, even as the cost goes up, it's just sort of continued to be valuable, and we've expanded. Like you think of the sheer number of people involved, not just in the design of the ICs, but the supply chain and the equipment down all through that is huge. It's an enormous pyramid and continuously growing, and that's one of the aspects that allows it to drive continuously faster. But someone put it to pretty well. I think I was on the Lex Friedman podcast with Neuralink, where our brain is a 20-watt computer that fits in the palms of we fit it in our hands.
Right.
And that is currently outcompeting data center sized
that's true.
inference computers.
Yeah, it's 1,000 times or more the amount of energy usage to do a single query.
Yeah, just orders of magnitude. And so Moore's law is driven by the cost and size, and there are driving factors behind Moore's law that have sort of continued to push things in that direction. But power efficiency has been improving as we've increased the density of semiconductors, but it's still just not even remotely close.
Yeah, absolutely. When I briefly at RPI got to run some programs on the supercomputer they had there, and the supercomputer was using an IBM processor or something. Yeah, and I was like, what is going on? And by the way, at one point in time, this was either the number 1 or number 2 biggest supercomputer in the world. And I was like, what is going on here? There's no way that this is the fastest. And they're like, no. The speed doesn't matter. Yeah. This is a hugely parallel machine. What we care about is the amount of power it takes to do one computation. I forget what the unit is. But that was the big thing. And when you list the table, whatever this IBM thing was, was doing quite well, relatively, even though it was a gigahertz. It was a really slow processor.
Yeah.
And the main, at least back then, supercomputers were great because they could run things massively in parallel and share data very, very quickly. Yeah. It wasn't so much that you had one processor that runs really, really fast.
It runs ballistically fast, yeah.
So that race is has kind of been going on in supercomputers, but now we actually care about it, I guess, for consumer devices, and that'll be like the new. There almost needs to be a Moore's law curve that's about power, I guess, is what we're saying.
Yeah, there's going to have. I'm sure someone's done the analysis on this as well, but the power per compute, I'm sure, is trending in a really interesting way as well. Even just with the costs you can see of inference on like whatever 4.0 and 4.0 mini compared to the Generation 3 ChatGPT models. It's incredible. I think it's 3 orders of magnitude cheaper than the previous generation of models, sort of token wise.
Yeah.
Which is like, it's huge.
Yeah.
It's insane.
Yeah. Oh, so exciting. Yeah. I don't know. Do you have a favorite kind of lightweight model? Do you use GPT 4.0 mini for anything or?
We've been using actually 4.0, whatever, latest.
Gotcha.
Good one or something like that.
The big guy.
The big one. Because we found out that you can actually give it, it's really good at reading. You can just give it an image of a PDF, and credit to the Omni AI team for publishing Xerox, Zerox, a library that did this first. And it will do OCR, basically speaking, by taking a PNG of the PDF and feeding it to an LLM. By default, I think ChatGPT 4.0, and saying, hey, give me markdown of this. And they've restructured a bit more and parallelized things and all sorts. And it does a really good job, and we're inspired by that. And we found that by feeding 4.0 images of a data sheet, you were able to extract information really effectively. Like, it was better in a lot of ways
than very cool.
Manually extracted data.
That's very cool. So I guess we're slowly piecing together all the parts of the equation for component selection.
Yep.
Maybe. So where is the missing data? Assuming we can read an entire data sheet, like one thing I'm thinking is kind of popularity. Because like you don't want to use something that not a lot of other people have used, but maybe sometimes you do. Like maybe your risk, like you're like, I have 12 months, I have a ton of time in a lab, I'll test tons of stuff. So maybe you don't care. So maybe that's a parameter. Data sheets can also vary in accuracy, right?
Yep.
Yeah.
And readability for that matter.
Oh, yeah. Yeah, like maybe I can get this component with a Chinese data sheet that does exactly what I want, but that's going to be a lot of friction.
Yeah, but I'm also not sure it does what I want. Whereas conversely, Texas Instruments, shout out Texas Instruments, always has fantastic data sheets in my experience. Yeah. And they include the application notes, and here's exactly how you set it up properly. And thank you. Like, incredible. That's true. I do hope that people start making data sheets that are a lot better, for the really low cost components. Although TI has like well priced, they're all over the place. Lots of stuff. They're gonna be all over. Is $1 cheap? I don't know. It depends for what. Like right. Have you ever had to swap a TI component or any component because like you were manufacturing it overseas and the supplier just couldn't get it? I've never dealt with this myself. That has happened to me. I believe it. For really basic stuff too. Like I was using a TI power, power FET or something, as part of a power regulator. And when I sent it over, they were like, we don't do this, but we deal with this issue so much that we have a Chinese alternative you can use. Wow. And we did it, and they replaced it, and it was like approximately the same cost. Were they unable to get them because of ITAR restrictions? Yeah, I think so. Wow. I think so. But on a component just for power, you know what I mean? It didn't make any sense to me. And for what it's worth, I can't really endorse this approach because the board was pretty flaky, and who knows if that was my design or the chip we replaced. Right. Yeah. So, but. Yeah, never been hit with that. I wonder how common that is. Oh, it's common. It happens. So, like a whole bunch of the supply chain teams, like job, generally speaking, is to find reputable suppliers that will continuously give you what you need at a high quality for a long time. How big is that team? I was talking to somebody at a public company, and they said they had departments dedicated to this for their products. But I can't
it's hard for me to imagine because I've only worked with really small companies.
Yeah.
So like, are these people on phones calling people all day, like calling suppliers and like doing spreadsheets? What goes on?
Spreadsheets, emails, like that type of thing. So they'll also do factory visits and like examine the production line. And sometimes like with the really good guys, we're working with a PCB fab and they said to us, sorry, we have a meeting with SpaceX immediately after. Those guys know more about whichever specific machine than we do.
Wow.
And like, we brought them in and they were expecting our line. They were like, yep, great, no worries, but you should really dial up XYZ parameter on this thing to improve yield in this way. And they were like, okay, yeah, awesome. Thank you very much.
Wow, that's interesting. How do they know so much? I wonder if it's because they go to like multiple PCB fabs and they see how everything is run. So they're basically talking to your competitors or something like that. Yeah.
I don't. People are pretty careful about that one because you want to have a trusting relationship with your supplier.
That's true.
But you might learn problems like textbook type information really effectively by seeing those types of problems. I'm sure you couldn't provide the solutions through that.
Right.
But if you've seen 100 times some defect that happens from some chemical reaction XYZ that's well published in literature, but you might not necessarily know about it, you perhaps do well to have been told.
Yeah, absolutely. I do wonder what the anatomy is of somebody who creates a PCB fab, because there are over 100 PC fabs in the US, and somebody who's created a fab told me, but I think a large one, but they were like, it's not that hard to make a fab. And it might just be like, the same way I would be like, oh, it's not that hard to make a website, just because you've done it a bunch.
Yeah.
But yeah, it's kind of like, it doesn't, like, there's nothing in my brain that says, oh yeah, that would be a really difficult part.
Yeah.
Whether it makes money or not, I don't know.
Yeah.
But the thing is the US government kind of subsidizes US PCB fabs in some sense because they will not ship things overseas.
Yeah.
And so you can get a lot of basically people who have to manufacture in the US to kind of spot your fab for you. But like, what do you need? And you're kind of working adjacent to this because in your office, I think you were mentioning for building this lab, you want to have a way to build PCBs and assemble them.
So we were talking about iteration cycle before, and I'd actually love to get your thoughts further on that topic in a minute. But in Shenzhen, you can get a PCB back. Like if you're there in person, you get a PCB like next day, like pretty easily. We in the Western world obviously know about GLC PCB and PCBWay, and there are more there. And we have options to do the one-click online order type thing with a 24-hour turnaround on a blank board, and assemblies even shorter. And so I think actually that subsidy is perhaps a bit of a double-edged sword where you have, a profitable company, but it's incentivized by government time horizons and incentives where they want like a N-year contract, and they're willing to pay, they're willing to sign a huge contract of millions of dollars to make sure that it all guarantees XYZ. I want a prototype tomorrow, And so they've been incentivized away from that in some cases. And again, having talked to a few of these fabs, some of them are like, nah, like more than happy to work with you. And they're really flexible. They're great people. Awesome.
Yeah.
And others are like, well, from a business perspective, how can I justify that decision? Because the government is more than willing to give me like almost easy money for the long-term stuff now that I've done it.
Right. But do you think it's easier, like if you were starting a fab, if you really wanted to somehow compete with JLC or PCBWay, but as a US company, do you think it'd be easier to like, okay, well, I can start getting all the equipment and stuff basically subsidized by the government, and then I can try to go for that next step? Or is there some kind of incentive, like incentivizing kind of longer timelines or something like that would just make you build the fab totally different when you're going after that first phase? Like I'm imagining having human assembly might be a trap because you might be able to afford that with some kind of government subsidy, but you could never do that for one day ordering or something like that. There's too much to manage.
So, well, the other thing to keep in mind is these types of companies in China are effectively subsidized by the CCP as well.
Right.
Like,
There's subsidies on both sides. Yeah.
And whether that's ignorance of environmental laws, where you say like, oh no, you can just tip this out, whatever.
I should probably say, arguably, there's much more subsidy on the Chinese side. Yeah. So just like backtracking a little bit, it's not. Yeah, it's not
it's not a one-way street. By any means. No, whether you look at that as a subsidy of an imparity of labor laws, environmental laws, whatever, that is you can consider that as a subsidy as well, right?
Right.
And so, how would it incentivize you to build a fab differently? I think it really comes down to what your customers want, because at the end of the day, the reason we have a free open market is to incentivize competition. As you said, setting up a fab it's not a triviality, but it's not that hard, really.
Right.
It's well understood technology. You can buy a line from a supplier that's set up thousands of them, and they'll sell you, like, here's machine A, B, C,
You can
D.
buy a whole line.
Oh yeah.
Whoa.
Like, it's just, yeah, sure. Like, you just buy it. Like, there's no custom equipment really required at all. All of these machines are off the shelf, right? Like, there's tens of thousands probably of fabs in the world in total.
And would you be using the same machines that they're using in China?
Probably not.
Probably not. Okay.
I'm not sure about that. I can't speak to that, but I can speak. So you were talking about our lab.
Yeah.
We hope to not have to make PCBs ourselves, just because it's like a fair bit of equipment, a fair bit of overhead. If you want that one day turnaround prototyping, then ideally we can make a partnership with a fab who's willing to do that.
Right.
But component assembly is like a little bit disjointed in the Western world at the moment. Typically, it's a separate assembly house, and pick and place machines are not that expensive, and neither are reflow ovens.
Right. Shout out to Lumen. Pick and place, open source pick and place.
Yeah, indeed. And Open PMP, the software, and there's a litany of them. I could think of, like, image wise, maybe not name wise, a half dozen open source or hobbyist level pick and place machines, and then you think of the industrial ones on top of that.
Yeah,
there's probably, like, stab in the dark, say 25.
There are so many pick and place. Kind of like companies or machines, like, it's just, there's something about that engineering problem that's like, that's a fun one, right? Like, it just has an appeal for people, I feel like.
Oh yeah, absolutely. And so, that's just one section of the line, but you got, like, whatever, call it something on the order of 25 companies and maybe 200 options in total to go pick of exactly how you configure that aspect. But then it's just conveyors and chemical baths before that. It's nothing wildly complicated.
Right.
There's a lot of expertise in there as well.
Yeah, fabrication, unlike maybe chip design. I'm really drawing some straws here. But chip design, I feel like, is hard to explain everything. But fabricating PCB boards or assembling them, it really isn't. A lot of times, like, if somebody has never heard of it, I'm just like, yeah, you're basically just gluing chips to a board that has wires drawn on it. And, that's not really how it works. There's chemical baths and all of these things. But, like, and for some setups, it almost is literally like that, because there's the ink PCB jars and stuff like that. Of course, none of that's actually really used. But
yeah, unfortunately, we did look into a couple of them the other day. The problem we had was that the conductivity of the traces was poor.
Yeah.
So it was fine for sort of basic circuitry, but as soon as you want to do anything with power,
you'd have to so it would get hot. It might also change as it gets hot, but it also has, like, resistance along the trace, right?
Yeah.
If you're drawing with ink PCBs, which could be a really cool technique. Do you know any of the parameters of that?
There was a huge variability for one. It was about 10 times the resistivity of copper for the same.
So basically, all of your traces are 10 times as long. But although,
not inductively and capacitively.
Exactly.
Yeah. Just 10 times the resistance, but also an enormous variability. And we asked what it was, and it was like plus or minus 100% from the middle figure they gave. Minus 90 and plus 100 something. It was an insane margin. And it was dependent on how you baked it. And anyway, so we looked at those. The other technology you can use to make boards really quickly is laser ablate the copper off.
Right.
And so there's a company that does this, that makes what seems like an incredible line, and I've never used one myself.
So laser ablate. I'm very curious about this, because I think your co-founder was mentioning this.
Yeah.
Laser ablate. does that mean melting the copper with a laser? Or
a couple further, you turn it into a gas.
oh, really?
Well, when the laser hits it, it's like
So you get it so hot,
Yeah.
it turns into a gas.
Yeah, it's like a high power laser. I presume a pulse laser, and so you have very short pulses that, as they strike the copper, they heat up. It doesn't have much time to conduct, so it heats up just really a superficial top level.
So copper, this thing that conducts super, super fast, you have this task of, because you don't
Notoriously
want to
hard to
gas
cut,
or
yeah.
melt too much. Wow.
Notoriously hard to cut. So typically with this type of process, I'm generalizing here because I don't know how these specific PCB fab ones work, but you have a high power pulse laser that for short duration, like nanoseconds or picoseconds, high power pulse that in the pulse itself has, whatever, thousands or tens of thousands of watts, but really short time. So the average power is only, whatever, call it 100 watts for argument's sake. And it heats up just the surface of the copper underneath it enough to vaporize it instantly. And then you have a small stream of typically just like compressed air or clean compressed air blowing that little gas out of the way, and you vacuum it up. And
Is copper gas, is that like...
I wouldn't want to breathe it, if that's the question.
It's not great.
It's not great. And you could filter for it without too much trouble.
Right. Not too difficult.
But, like you can get copper poisoning from copper cookware if you put acidic things in it for too long a duration.
Oh, really?
Your eyes will go blue. Not like vivid blue, like X-Men style, but you'll end up with like blue little lines in your iris. Yeah.
Wow.
So anyway, don't go huffing.
Well, if the machine has a leak.
Yeah.
Everyone turns into... who has blue eyes? Nobody has blue eyes. I'm trying to think. I was going to say Avatar. No, they don't have blue eyes.
I've seen... I saw some prisoners, some US convicts who tattooed the whites of their eyes blue. So someone...
That's crazy. That's so risky. I know people who are afraid to get LASIK because they're afraid because for a very small percentage of people, LASIK can hurt their eyes.
Yeah. No, fair enough. I don't
So
mind.
imagine going in for a tattoo.
Oh, wild stuff. Wild stuff. I wanted to bring back up actually the iteration cycle we were discussing before, because I've got some thoughts on this that I've had vividly disagreed with, but I think are more common in Silicon Valley. So I wanted to voice them and hear your opinions as well.
Yeah.
Basically, that taking appropriately sized chunks, and that varies with how well you understand what you're doing, and building, testing, iterating on that is by far the fastest way to create something. And I'd posit, I think that the brilliance of this area of Silicon Valley and San Francisco is that they're willing to take way smaller chunks and build way jankier things, way worse things by many metrics, and try them out in real life than anyone else. But you actually end up moving much faster for it. And I think you can prove this out mathematically with a little calculus as well.
Yeah. It's tough because it's really like it's almost a three-dimensional thing, but I feel like there's some history to like iterative development.
Yeah.
Like there was this whole lean startup mentality that was huge. It was huge 10 years ago. And that mentality basically said, like, talk to your customers and just keep building out what they want and do these like little iterations, and it always gets better. It's always getting better. And then so maybe you start like a little bit janky just to deliver value, but it's such a small increment and it's all very, very small. And then I think like 0 to 1, Peter Thiel was more like, hey, building innovation is really going 0 to 1, and a lot of people interpret that as we've got to make a huge leap. We have to build a huge rocket, right? And really like get a bunch of money for R&D and do something that humans have never done before.
I remember in that book as well, he was he drew a grid of positivity and imagined or positivity and creativity, I think, were roughly the two axes. And you have to be positive about the future and highly creative. I think
That's right. It's definite and indefinite, and then optimism and pessimism. Is that right?
That sounds right. Yeah.
Yeah. So the idea being indefinite optimism is kind of bad, if I remember correctly. Like being like, the future will be better, but I don't really know how. And a definite optimism is being very sure. Like that's the kind of the 0 to 1 thing is like, I am the future is going to be better and it's going to look like this, being very sure about the future. And that way you're able to take a bigger leap without, kind of doing this lean startup validating against customers and stuff like that.
It was funny as well because I remember in the pessimistic, eat, drink, and be merry because tomorrow the world will end corner of this chart. He'd said, and this is the problem with European startups is that they often live down here, and Europe often has this culture of like you can imagine the Frenchman smoking a cigarette. Well, I'm going to die anyway, and so they go for it. And I even saw this just last night at Brian Johnson's talk, is there was a couple of European people there who just could tell from their accents, who kept sort of down this train of thought of like, well, what about enjoying your life while you're here?
Right.
So it's really interesting to see how much that varies throughout the world as well.
Yeah, absolutely. But yeah, so much to unpack. But on the iterative development, I think that where we're moving is kind of a little bit of overlap between lean startup and 0 to 1, because we don't want people making stupid big steps, but also a lot of really great ideas look stupid when you take essentially that big of a step. I think like a really big step example is kind of like, I bring it up a lot, but Humane Pin, because they like where they just like really, there was no increment, with that thing. And many people might say that there couldn't have been an increment, right? But I think in some ways there could have been, and you see them now. Friend.com is an example of an increment of a hardware product that it's an AI necklace, much cheaper, or it appears, well, literally much cheaper from a cost perspective. But it's not some crazy construction. It's just a thing you tap, and it's listening to you and responding to you.
You might even argue that the interim step there is an iPhone app.
yeah, absolutely. AI companion on iPhone. Like there's a lot of ways to validate it. I think figuring out that step size is really important. I don't know if I have the best framework for doing that step size, but certainly the lean startup mentality of customers are going to lead you in the right direction is not always correct and won't always get you to innovation.
No.
But spending 2 years working on something and not releasing it is also very, very bad.
Absolutely. Do you have a sense of why this mentality has shifted over the last decade?
Yeah, absolutely. I think the lean startup ideas, like they are essentially low-hanging fruit. Like things that people will kind of know should exist, that's common knowledge, or that you can kind of iterate to, that's being exhausted. And so I think, when I was talking to investors, this was definitely apparent that when you have something a little bit weird, but checks some of the boxes of like, I think the future will look that way, that's far more interesting. Like we talk about previously, kind of modularized circuits or generating circuits with AI. That's interesting. Like if you believe that the future will look like that, how do you work backwards? There's some weird stuff in between maybe. And so trying to convince them of the weird middle is always fun. And then
I think the low-hanging fruit's spot on. I was thinking the exact same thing. You even see some of the companies or the proportions of companies that Y Combinator has been accepting over the decades, started out super software oriented, and now an enormous part of the batch is biology and like hard tech.
There's a lot more hard tech.
It's a section that's growing enormously. And frankly, even just big, even when I was there,
Yeah, I think YC recently funded its first like defense company.
Oh, interesting. I'm not sure about the first. Only
it might not be the first. That doesn't sound right. So I'll check my facts on that one.
Yeah, another big one. There's so much interesting stuff. I think though that you're right, and that the surest way to make a profit before was take the low hanging fruit, because it's sitting there and you would be insane not to. But now that low-hanging fruit has largely been consumed, okay, what's next? Well, Elon's done a damn good job showing that, like, you can build hard tech companies, deep tech companies. Like, God.
You can build two at once.
If you really want to, I guess. It's possible. And I think that has been pretty inspirational for a new generation of people who are willing to dream positively and big about the future, and willing to take a huge risk. And with all the additional capital that these investors have from the smaller bets that they've made over the years, then we get to try some of these enormous things out. Right.
And I think with technology is the thing that you can have your cake and eat it too. Like when people thought about sustainability and electric vehicles and stuff like that, they were like, well, I'll have to make some compromises because that's a narrative within sustainability a lot of times, not all of it, but a lot of times it's, so we'll use less of this, or we'll start doing this instead, and it'll be a little bit more inconvenient or cost a little bit more. But Elon was like, no, we'll make a better car and it'll be electric, right? And that's what technology does. You get a better version of in many aspects all at once. And so I just like how the narrative can change in that way. Like,
absolutely. I think the really interesting thing is it's almost like The Sims, where you get like, you roll the dice and you can up or down characteristics, and you're really going for the highest points possible. And some you're never going to accept a 16 or something. And sometimes if you're really lucky, you get an 18, and you can move those points around how you like. And I think that the environmentalist movement and activists generally would be best off, and are best off, when they say, okay, let's ensure here's a minimum viable standard. We continue to push in this direction, and you leave enough points that you're not degrading the standard of living from the other categories. You want that to be on the up as well, because that eternal optimism that, whatever, I can have better quality food at the same time that it becomes sustainable is a pitch that everyone is listening to. All you're asking is for more of the points, the net points to be put into that category, but they can all grow simultaneously, all remain on the up.
Right. Well, makes sense to me. We've been going for about an hour. We're really did a big loop on topics on this one. But I enjoyed it.
Thanks for talking, Seve. I always enjoy it, mate.